Welcome to our maths class, and today we are going to solve the inequalities. Earlier on, we saw that when we talk about inequalities, we are trying to find out whether the left-hand side is either greater than, less than, equal to the right-hand side. Now, these inequalities can also be solved. Sometimes we find that a problem may arise in which when we try to find an inequality, we find it is more complicated. Look at this. X is greater than 5. Or y is less than or equal to 40. When you have this, it is only trying to tell us that the values for x are values that exceeds 5 and onwards. Anything less than 5 is not going to fit this inequality. And for this one, the values for y are 40 itself inclusive and below. This is a straightforward inequality of which we find we can assign the values. The solution of this inequality for x is simply all the values that will make this inequality true. But sometimes you'll find an inequality like 2x plus 4 is greater than 100. Now, this one, we cannot just say the value of x is this. It needs to be solved. So what is it when we say we are solving inequalities? To solve an inequality means to find all the values that can make this inequality true. So if we were looking at this case, look at the value. When we substitute this, will give us, will be greater than 100. So take, for example, if x is 0, then the inequality becomes false because 2 into 0 plus 4 is greater than 100. This will be equivalent to 4 is greater than 100. This is false. So how do we approach this question and solve it? We want to get the values for x which makes the inequality true. So you'll notice that for larger values, like if we were to say x is 100, definitely it would be a true value for this. But we want to find the true value for x on this inequality. For us to do that, we need to solve the inequality. Solving inequality simply is done in the same manner on how we do it in the equation, considering the right-hand side and the left-hand side until we arrive at the simplest inequality. Now, let us look at this. If this was an equation, I want you to relate this is an equation. This one here is an inequality. If this was an equation to be solved, we would subtract 4 both sides like that, so that we have 2x is equals to 96. And then we divide by 2, you find that x is equals to 48. For this other side, we have to maintain the inequality. So the procedure remains the same, but the inequality is observed clearly to remain the same. So the first part, we subtract 4 on the right-hand side, subtract 4 on the left-hand side. We remain with 2x is greater than 100 minus 4. So this is the same as 2x is greater than 96. Then we shall divide this side by 2. And the right-hand side also divided by 2, so that you have x is greater than 48. Now this is the solution for this inequality, which means x is all the values that are greater than 48. And remember, if we have it this way, 48 is not inclusive. So all the values greater than 48 will solve and make this inequality true. The only difference comes when you are dividing by a negative or multiplying by a negative number. If that case happens, then the inequality sign changes. So given an inequality, an equivalent inequality can be obtained by doing the following. First is by simply adding or subtracting, an expression from both sides. It can be obtained by adding and subtracting an expression from both sides. Also, you can get an equivalent inequality by multiplying or dividing both sides by a positive number. Multiplying or dividing both sides by positive number. Now, if we happen to multiply or divide by a negative number, then this one will bring in a different approach about the inequality symbol, because it will require that the inequality symbol changes as we are going to look at it. So, but for adding and subtracting an expression from both sides, multiplying or dividing both sides by a positive number will always make an inequality to remain equivalent without changing anything. So we can still keep on obtaining the similar or equivalent inequality by multiplying or dividing both sides by a negative number. And in this case, we shall be required to reverse the inequality symbol. So, multiplying and dividing both sides by a negative number and reversing the inequality symbol. I want you to consider the following, and then you see why this particular point is necessary. We all know that 5 is greater than 2. Let us have also 5 is greater than 2. Now, we want to divide both sides by, one side by a positive number, another side by a negative number, and also multiply one side by a negative number, another side by a positive number. So let us start by multiply by positive 1. Multiply by positive 1. You'll get 5 multiplied by 1 is 5. The sign remains, and 2 multiplied by 1 is 2. This other side, if we multiply by negative 1, 5 multiplied by negative 1 is negative 5, and 2 multiplied by negative 1 is negative 2. Now, when you look at this one is true, it remains 5 greater than 2. But is minus 5 greater than minus 2? As we saw yesterday and in the previous lessons, you find that on a number line, the numbers that are on the left-hand sides are smaller in value than those ones on the right. In the number line, if we are to have a number line, then it will mean that we shall first get negative 2 before we arrive at negative 5. So you notice that negative 5 is less than negative 2, but not greater than. So this statement here is false. So how do we make that statement to be true? That's why we've said if you happen to multiply with a negative number, then you'll have to reverse the inequality sign. You'll have to reverse the inequality sign. If we reverse the inequality sign, will it give us the right explanation? Let's see. 5 is greater than 2, multiplied by negative 1, and then this side multiply by negative 1. So this one, you get minus 5, and then you reverse the inequality symbol to be facing the opposite side, and then it will be negative 2. The inequality now becomes true. Negative 5 is less than negative 2, which is very, very true. Supposing we were dividing. Let's have this. An inequality 2x is greater than 6. An inequality 2x is less than 6. And from this inequality, we want to see what will happen when we divide with a negative and when we divide with a positive. Now, take an example before we approach this. If we had a number like 4 is less than 6, that is true. And then we divide both sides by negative 2. Divide both sides by negative 2. You'll find this one becomes negative 2 is less than negative 3. If you look closely on this statement, it is false because negative 2 is on the far left side of negative 3 is on the far left side of negative 2. Therefore, negative 2 is supposed to be greater than negative 3. So the statement here is false. So how do we make it correct. It is when we divide with a negative number, we shall be required to reverse the inequality symbol. So let's do that and see. So here, we shall have to reverse. So divide by 4 divided by negative 2 is negative 2. And then 6 divided by negative 2 is negative 3. And then we reverse the inequality symbol like that. And this one is a true inequality. So we are saying that when dividing by negative numbers, we must always remember to change or to reverse the inequality symbol. Last point about inequality being equivalent is swapping the left hand side and the right hand side, and you reverse the symbol. You can obtain an equivalent inequality by swapping You can swap the left-hand side and the right-hand side and reversing the inequality symbol. That is what you can also do. So for this case, we can simply have an illustration to show this. If you have a statement reading 5 is less than 7, when you swap, it will be 7, reverse the sign is greater than 5. This statement is true. So all the 4 steps that we've discussed allows us to obtain an equivalent inequality. All of them allows us to obtain an equivalent inequality. Solve the following inequalities. 5x plus 2 is less than 47, and 3 plus 4x, 3 plus 4x over 9 is greater than or equal to 3. Now, as we have seen earlier on, the approach is done the way we do it in equations, working in a systematic way. So for this, we shall start by simply subtract 2 on both sides. When you subtract 2, this will be 5x is less than 45. And then we divide by 5. 5 is a positive number, so nothing changes. We shall remain with x. The sign will not change because we have not divided by a negative number. 45 divided by 5, you will get 9. So the solution for all the values of x that satisfy this inequality is x is less than 9. X is less than 9. You can also represent these solutions on a number line. Having solved the equation, you can simply represent your solution on a number line, of which if you have the number line, and this is 9, 8, 7, 6, 5, 4, 3. We can simply represent the solution by saying x is less than 9. So we go to 9 and have an open circle to show that 9 is exclusive and the direction it takes is this direction. So this is the solution for this particular inequality. X is less than 9. We also have those inequalities which are fractional, and we should also approach them the way we normally approach all the rest. So this one is one of the examples. We have 3 plus 4x over 9 is greater than or equal to 3. So for this, the very first approach, because the whole of it is over 9, then we shall have to work out on getting the 9 out first as we proceed. So the first thing we need to do here is to approach this is by multiplying both sides by 9 and multiply the other side also by 9. When you multiply by 9 both sides, you remain here with 3 plus 4x is greater than or equal to 27. Is greater than or equals to 27. So when you look at this, now, it's a simple inequality which can also be handled systematically. So we shall subtract 3 and subtract 3 and this other side. When you do that, you remain with 4x is greater than or equal to 24. We want to find all the values of x that satisfies the inequality that we have. So the true values for x here, we shall have to divide both sides by 4. And when you divide by 4, we shall remain with x. Because we were dividing with a positive number, the inequality symbol does not change. So 24 divided by 4 is 6. So at that point, the solution for this inequality is x is greater than or equal to 6. Again, on the number line, you can come and represent the information on our number line. So we identify where x is greater than or equal to 6, which means 6 is inclusive. So we shall have a closed circle. A closed circle means the point where we're starting is inclusive. So 6 here is inclusive, and it should be greater than 6. So it will move that direction. So that is the solution for x is greater than or equals to 6. We have 15 minus 2x is greater than 1. Is greater than 1. Now, for this, it's an inequality where we want to see how we approach inequalities which will involve negative as the coefficient of x. So, the first step we take, we shall simply subtract 15 on both sides to remain with minus 2x is greater than 1 minus 15 is minus 14. 1 minus 15 is minus 14. And then we divide both sides by negative 2. Because we are dividing with a negative number, take note of the behavior of the symbol. It is supposed to change. So the inequality symbol will change. If it was facing on the left, the right, it will change and face on the right. So this one will be minus 2 divided by minus 2, it will give us a positive x. Now the sign will change like that, and then we shall have minus 14 divided by minus 2, which will give us 7. So when you look at this, 7 is less than, sorry, x is less than 7. If x is less than 7, then this is our solution and can be shown on the number line the way we've seen. But the major area of concern is the behavior of the inequality symbol when we divide it by a negative number. So let us go looking at other way on how inequalities are given or approached. We are to classify the following inequalities as true or false given that x is equals to 3. First one, x plus 4 is greater than 2. 5x is greater than or equal to 10, and 10 minus x is less than 5. For us to show whether the statement or this inequality is true or false, we shall be required to substitute the value of x and see if it fulfills what we have. So for the first one, x plus 4 is greater than 2, but x is 3, substitute there, so we have 3 plus 4 is greater than 2, which is 7 is greater than 2. This is true. So we find that the first statement is true for x is equals to 3. It proves that the left-hand side is greater than the right-hand side. For the second part, 5x is greater than or equals to 10. Looking at that statement, x is 3, so 5 multiplied by 3 is greater than or equal to 10. When you multiply this out, 5 times 3 gives us 15, is greater than or equals to 10. This statement may be true or not true depending on where you choose to settle. If we use equal, 15 is not equal to 10, but it's true 15 is greater than 10. But from this case, we look at 15 being greater than or equal to 10. This statement is telling us that it's a true statement because it satisfies the inequality. For the last one, 10 minus x and x is 3 is less than 5. 10 minus 3 is 7. 7 is less than 5. Is it a true statement? You'll notice that this is a false statement because in ordinary situation, 7 is always greater than 5, but not the other way round. Let us look at inequalities involving fractions. Q plus 4 over 2 is less than or equal to 11. So the question is solve Q plus 4 over 2 is less than or equal to 11. The approach is the same. We multiply the left-hand side by 2 so that we remove the denominator, and multiply this side by 2. So you'll find that this is q plus 4 is less than or equal to 11 times 2, which is 22. Our interest is to find the value of the inequality for q. So subtract 4 this side to get q. The inequality remains, subtract 4 the other side to get 18. So the inequality that satisfies that equation is q is less than or equal to 18. There's a situation where now we have a pronumeral for the inequality appearing on the right-hand side, and we are used to solving those ones with the which are appearing on the left-hand side. Solve solve 20 is greater than or equal to 2 minus 9v. 20 is greater than or equal to minus 9v. First approach, we have to work out by subtracting 2 this side and also subtracting to this other side. You'll find that you have 18 is greater than or equal to negative 9v. Then you'll divide by negative 9 here. Divide by negative 9 on the left and on the right to remain with 18 divided by negative 9 is negative 2. Because we are dividing with a negative number, the inequality will change from being greater than or equal to less than or equal to, and this one is v, which is positive. So this is the value for v, which is equals to negative 2. We would also have approached this question the same way, this way. By swapping, we swap the left-hand side and the right-hand side, and then reverse the symbol. So swapping the left-hand side and right-hand side and reversing the inequality symbol. How is that done? So 2 minus 9v will come on the left, and then the symbol will be reversed to read less than or equal to 20. And then from there, you can go on and work by simply subtract 2, you come up with minus 9v is less than or equal to 18. Then divide by negative 9. Divide by negative 9. You get v, which is positive. Reverse the sign because we are dividing, is greater than or equal to negative 2. That is, if you swap the left-hand side and the right-hand side. The third way of which you can still approach such similar question is by this time choosing to subtract a pronumeral, that number with a pronumeral, instead of simply starting to solve. Let us try the third way. (20) is greater than or equal to minus 2. So this approach, we decide to add 9v on both sides. So we shall add 9v, add 9v. When you do that, we shall have here 20 plus 9v is greater than or equals to, we have the other side negative 2. We have the other side not negative 2 but a positive. So this is what you get. 20 is less than, 20 is greater than or equal to 2 minus 9v. Subtract 9v this side to get 2. By adding 9v this side, that is minus 9 plus 9. 9v minus 9v plus 9v is 0, so we have 2 remaining. And then 20 plus 9v on the left-hand side. Then we now follow the ordinary procedure. Subtract 20, you get 9v is greater than or equal to negative 18. Then we divide by 9. Divide by 9, you find v is equals to negative 2. So there are 3 ways of which you can approach this question without any problem, and we are able to solve it. So we can simply handle inequalities with the negative coefficients in those 3 ways. Now, we have seen pronumerals on our inequalities appearing either on the right or on the left. But we have a situation where there are pronumerals appearing on both sides. If I take you back to when we were handling equations, it reached a point where we would have the pronumerals of the equations on both left and right hand side. In solving inequalities, the same way we solve equations is the same way we shall approach this. We need to collect the like terms. Then, after collecting the like terms, we move ahead now and form a simple inequality that we can solve. So let us look at inequalities with pronumerals on both sides. This is just an example of pronumerals of pronumerals on both sides. So when we look at this inequality, we have x on the left-hand side. We also have x on the right-hand side. So how do we best approach this particular question? So we need to collect the like terms so that we are able to deal with this. So we shall start by, we need to bring this the other side, so we shall subtract 10x, subtract 10x. So this one will be 12x minus 10x plus 5. The sign remains, and we have 11 remaining. Then you do what? Here you will collect like terms. And like terms here are terms that have x. So 12x minus 10x is 2x plus 5 is less than or equal to 11. From here now, we have reduced it. We only have pronumeral on one side. We can go ahead and solve our question by simply subtracting 5 on both sides, so that we remain with 2x is less than or equal to 6. Then we divide by 2, divide by 2, you get your x is equals to positive 3. So we can solve pronumerals with inequalities with pronumerals on either side, that is left-hand side and right-hand side. Let us look at questions relating to this. Now we have 7c minus 5 is less than 10c minus 11. We have on both sides pronumeral c, so we need to collect like terms, bring them together, and then we see how to approach it. It can go either side. So I want to start by taking this. I'll subtract 7c here and subtract 7c the other side, so that I have 7c minus 7c minus 5, this minus 5 is less than 10c minus 7c minus 11, which can be reduced to 5 is less than 3c minus 11. At this point, we add 11 on both sides. This one will give us positive 6 on the left-hand side. It will give us a positive 6. So on the left-hand side, minus 5 plus 11 is the same as 11 minus 5, which is 6, positive. The side remains less than. And then we shall have on the right-hand side 3c. So having subtracted 11 from both sides, so what will follow is that we shall divide this side by 3 and divide this side by 3. If we divide both sides by 3, we are going to have 2 is less than c. Remember, we are dividing by a positive number, so the inequality symbol will always remain. If one you chose to go by simply removing the 10, we would have 7c minus 5 is less than 10c minus 11. So if one chose to use this, we would take this side, subtract 10c, and subtract 10c this side. If we subtract 10c both sides, we are subtracting 10c both sides. We shall have 7c minus 10c minus 5 is less than minus 11. Then we go ahead and combine 10c here is a minus, so 7c minus 10c, it gives us, this one gives us negative 3c minus 5 is less than minus 11. Add 5 both sides, plus 5, plus 5. You find that minus 3c is less than minus 6. Then we divide by minus 3, divide by minus 3. You get c. Now we are dividing, so the symbol does what? Changes or is reversed. So it will be c is what? Is greater than 2. C is greater than 2. So we can simply work out again the same if we don't want to start from the right-hand side. Sometimes we have an inequality, and in this inequality this time we have it in bracket manner. If we have inequality which is in brackets, we should not see it differently. We should just be able to handle it the way we have handled other equations with brackets, by first expanding. And to expand, we shall still observe the rule of the distributive law, and that law of that distributive law, the way it applies in the equation will also apply here. So we expand by removing the brackets, and then we collect the like terms, maintaining the inequality, and then we follow the procedure until we solve this. This is an example of brackets with inequalities with brackets. Now this one we shall first be required to deal with the brackets until we remove the brackets. The process of removing these brackets is called expanding. So we expand this inequality. And to expand this, we use distributive law. And using distributive law, as we saw earlier on, we shall take 2 multiplied by this, and then 2 multiplied by 1. So we shall have 2 times 3p, which gives us 6p, plus 2 times 1, which is 2, is greater than 4 times p, which is 4p, 4 times 2 is 8, and then plus 3. Then collect like terms where necessary. So we have 6p plus 2 is greater than 4p plus 8 plus 3, which is the same as plus 11. Now you see at this point we have the pronumeral on either sides. We have the pronumeral on either side. So we can still go ahead and say we want to remove this, so we subtract 4p from both sides, so that we have 6p minus 4p plus 2 is equals to 11. When you combine this, you find you remain with 2p. So we shall remain with 2p. That is 6p minus 4p is 2p, plus 2 is equals to 11. And then we shall subtract 2 both sides, so that we have 2p. It's not an equal sign, we are using an inequality, and the inequality is greater than. So we are having, when we did subtract minus 2, it is 2p is greater than 11 minus 2, which is 9. So we have 2p is greater than 9. We shall divide this side by we shall divide the left-hand side by 2 and the right-hand side by 2. Take note that we have 2p is greater than 9. So what will remain is p is equals to 9 over 2, or 4.5. So it's not always a must that you are, it's not always a must that the value of p will be a whole number. It can also be a fraction, it can be a whole number, and so on. For this case, it's an improper fraction of 9 over 2. That is what we have there. So we are saying that when you are handling inequality with brackets, you'll use the distributive law to expand or to remove the brackets. Having removed the brackets, now you go and collect the like terms, and then you simply bring the inequalities with the pronumerals on the same side, and then we solve it to get all the values that satisfies the inequality. For this case, it is p is greater than 9 over 2. So this is how we approach those inequalities which have brackets, and at the same time they have pronumerals on either sides. In some situation, when you are dealing with the inequalities, you can find that we are required to have to read out a statement. Katik buys 4 cartons of milk and a $20 phone card. The total cost of his shopping was greater than $25. If C is the cost of a carton of milk, write an inequality to describe this situation. Write an inequality to describe this situation. So we want to find an inequality that will describe the situation, given that C is the cost. Of a carton of milk. And how many cartons are bought? There are 4 cartons. So that implies 4 cartons, that is 4C, that's the total cost of 4 cartons, plus $20 is greater than 25. 4 cartons plus 20, 4C plus 20 is greater than 25. This inequality actually describes the statement that we have above. Then we go ahead and solve this so that we can find the possible values or the possible cost of a carton, what is its range. If you look at that, so solve the inequality to find the possible values of C. The inequality is 4C plus 20 is greater than 25. So we can solve that. To solve this, we need to apply to work out systematically. So minus 20 both sides. So we will remain with 4C is greater than 20, is greater than 25 minus 20, which is 5. So divide by 4, you will remain this side with C. You remain on the left-hand side with C is greater than 5 divided by 4 can remain 5 over 4, which can also be written as 1¼ because remember this is the value, the cost that is in dollars. So C is equivalent to 5, if C is greater than 5 over 4 dollars. So that is how we approach this particular question when we are looking at the phrases or a statement or word problems where we shall first be required to describe the situation using an inequality. Having described the situation using an inequality, you go ahead and solve the inequality accordingly. So that is it for today. And in our next class, we shall be looking at a different area on measurements. Thank you.